Good morning and welcome to NSC News. This is Wilma and today's topic is about the Great Barrier Reef, which is under a big threat. Today I'm going to talk with some experts about this subject. Our first guest is the marine biologist Ellen Frost. Hello Ellen, and welcome.
Thank you, it's great to be here.
Can you start with telling us what's really threatening the barrier reef?
There's two main reasons. The first one is the ocean acidification.
But what is acidification and why is this a threat to the barrier reef?
Acidification means that the pH level in the ocean drops and results in an acidic ocean. An acidic ocean contains less aragonite. And aragonite is very important for the reef because it's the substance that the corals build up their limestone skeleton of.
But why has the acidification developed?
The acidification had developed because the chemistry of the ocean has changed. Simplifying it, you can say that more carbon dioxide from the atmosphere is absorbed and dissolved into the ocean. And the carbon dioxide reacts with other substances and prevents the forming of aragonite.
But carbon dioxide exists naturally in the atmosphere. How come did it now become a problem for ocean acidification?
Mainly, the reason to the acidification is the burning of the fossil fuels that have increased the amount of greenhouse gases in the atmosphere, especially carbon dioxide. That means that there is more carbon dioxide for the ocean to absorb, and which means less aragonite and a more acidic ocean.
But what does the acidification do to the coral reef?
The acidification makes the corals shrink. Due to less aragonite, the limestone skeleton becomes weaker and can't resist the natural erosion that occurs in the ocean, and the amount of corals will then decrease. Corals take a very long time to rebuild themselves, so the damages of the erosion on the weakened corals is devastating.
Ellen, do you have something more to say about this subject?
There's always more to say about the reef, but my colleague Adrian can tell you more about it.
Thank you, Ellen. Over to Adrian Kalutra. Hello, Adrian. Thank you for joining us.
Hello, Wilma.
Can you tell me more what's going on in the reef right now?
We have studied the reef for a long time and have recently noticed that more and more species are fleeing the reef, despite it being their natural habitat. A good example are the clownfish.
Can you tell us more about the reasons that the species are fleeing the reef?
Except the acidification, the coral bleaching is the biggest threat against the barrier reef. When corals are exposed to stress, they will grow slower and become more vulnerable to diseases. If the stress is big enough, they will eventually die, and since the corals are the most important species in the reef can't survive without them.
What kind of stress can they be exposed to?
The main source of the stress is the variation in the temperature. As an ecosystem, the barrier reef is very sensitive against even minor changes in the temperature, and the temperature is increasing because of the global warming.
We are now talking about what's destroying the reef, but why is the reef so important?
Scientists have recently discovered that some of the species can be used in medicine, for example as medicine against Alzheimer's, so it's very important for humanity. But of course they are important for the marine life in the oceans as well. Billions of species are depending on the reef for food and shelter. We estimate that at least a fourth of the marine life lives in the coral reefs. So the biodiversity in the ocean depends on if we can save the coral reefs from acidification and coral bleaching. Without any corals, these beautiful and unique species can't be found anywhere else in the world and might become extinct.
This sounds terrible, but is there something we can do about it?
Marine biologists are now working on getting a better insight on how the acidification affects the coral reefs and finding a solution to this problem. You can also help by lowering your carbon dioxide emissions and in long term help the carbon dioxide level getting lower in the atmosphere, which will help to stop the acidification.
And hopefully save the Great Barrier Reef before it's too late. Thank you, Adrian, and thank you all who have watched the show tonight. Tune in tomorrow for new natural science news. Have a nice evening.